So, section D is really all about word problems, which I know, grown word problems. But I'm going to tell you the word problems are probably what you might see a little more often. And the word problems they will refer to is sinusoidal functions, just sine-like functions. All right, so don't freak out. All right, so let's look at this example. First of all, I'm just going to write the function here. It looks exactly the same. And this is in degrees Celsius. It says sketch the graph of D for, very important to pay attention to the interval. So the first thing, time is always on the x-axis. So that means I need to check my period first. Period for cosine is normally 2 pi. Then we divide it by the coefficient of t. So if I take 2 pi divided by pi over 6, that's multiplying by 6 over pi, multiplied by the reciprocal. Pi goes away, so our period is 12, which should make sense that it takes 1 full year to get back to starting to repeat itself. But we're going to have to show 2 years, 0 to 24 is 2 years for our interval. All right, so first of all, I'm going to go 1, 2, 3, 4. That's my first year. I'm going to get my first cycle in. 1, 2, 3, 4, 24 months. So this is going to show every 3 months. Then I'll go all the way up to 24. Okay, the next thing that we're going to add is our vertical shift is up 20. So let's go 10, 20. So here's my midline or principal axis. Amplitude is 5. So notice if this is 10, it's important to label your axes. So this amount here, I'm going to go up 5 and down 5 from my 20. And that incorporates everything because we've already got our period, our amplitude, and our vertical shift. Okay, so cosine starts up from the midline and goes to equilibrium, then down, back to equilibrium, 1 full cycle by 12. Then I'm going to do it again so I have my full interval that they want me to show. All right, so that's section A. What would the average daily temperature be? All right, so your average temperature, during May. So that's where we got to kind of think about what is May. So we have, and this is, where does it say? T is the time in months after January. So you got February, March, April, May. T equals 4. So we're just going to, I'm going to erase this here. So what was important for this question is May directed us, we had to think about T in terms of time in months after January. So if T is 4, I want D of 4. So if I take 4 times pi over 6, this can simplify into 2 pi over 3. So I need to find cosine of 2 pi over 3. So 2 pi over 3, I'm going to come down here. If I graph 2 pi over 3, remember this is pi, so 2/3 would be here. So this is 1/3, or 60. So this is 1, 2, square root of 3. And cosine is -1/2 x over r. So we get 5 times -1/2 plus 20. And that gives us 17.5 degrees. All right, so if we kind of look at that, does it make sense? That's where the temperature's a little bit less. Okay. All right, and it doesn't tell us where this is at, but so to me it's backwards that it's the highest temperature in January and then goes down. So this is in a different part of the world than we are. So what's the minimum average temperature and what is the month that it occurs in? All right, so when do we hit our bottom? That's when T is 6. Minimum's the bottom of the graph. And, and that month would be, well, if this is May, June, July, then we just want to plug in 6 into our equation. So we want to find D of 6. So we have 5 cosine. 6 times pi over 6 is just pi, plus 20. Pi, we can just use our cosine curve. That's -1. So -5 plus 20 is 15 degrees Celsius. We should really put our Celsius here also. So that's a lot, but one of the things that I think makes tough is finding this cosine of 2 pi over 3 and sketching this out. Or understanding that cosine of pi is just on the cosine curve and figuring that part out. So there's a lot of information here. Okay, on a hot summer day in Madrid, Antonio pays careful attention to the temperature. The max occurs, that's the max temperature at 3:30. The min, so organizing your information, it doesn't say what time. All right. And it wants a sine function to model this. Okay. So first, so if this is our max and this is our min, does it make sense? We want to find the average of this to find the midline or the principal axis. So I'm going to take 41.8 minus, hang on a minute. We're averaging the two, right? So we're adding. All right, and this gives me 34.65 to find the average temperature. All right, so the average in between when we subtract, that actually finds the amplitude. So let's go ahead and find the amplitude right away, the distance from the top and the bottom. That's where we take the high minus the low and divide by 2 to find that distance. Or you could subtract the high minus this one. Lots of ways to get that answer. So this is our amplitude. This is our vertical shift. We're getting close. Let's think about our period. All right. So this is talking about a year, right? Hang on. Oh, for that day. So how many hours in the day? That's going to be 24 hours. So that's why it's important to maybe underline, circle, highlight, whatever you need to, the important information. All right, so period, we always take 2 pi divided by our time, and that's going to be pi. This is, oh, our period is 24, so this is finding our b value. Okay. All right, so we've got, this is the number that's our coefficient of x. This is what goes out front, and this is what gets added. The only thing we're missing now is our phase shift. All right, so think about a normal sine curve right here. In a normal sine curve, this is 24 hours, 12. Does it make sense that it hits the maximum point at 6 hours? All right, so if the max point occurs at 3:30, that's 3:30 in the afternoon, that means when does it start here? We're going to take our 3:30 in the afternoon minus 6 hours to put that back at equilibrium. That's going to be 9:30, which 9:30 is 9.5 in terms of numericals. So this is clock time. So be careful. 9:30 is 9.5. So let's incorporate everything into our function. We start with our amplitude, how the distance from top to the middle. Sine of b x, and I'm going to put the x minus our phase shift in the extra parentheses plus our average temperature, which is the middle point. That's how far it gets shifted up. So this one's a little tougher, so you might want to re-watch it and see if you gain a few more pieces the second time through. And our last one. So this just says if we want to fit, because not all temperature, it's not going to be perfect, is it? And so with this last one, what we're going to do is draw a scatter diagram. That's super annoying, but notice it's one time is in month. I'm going to kind of come down lower here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's our December. This is the month of January, from January 1 to January 30th. And you can also, if you want to write January, February, if that makes more sense, underneath. Okay. Yeah, and they kind of explain that. Okay, so then we're going to graph. Notice we've got to look for our high points and our low points. All right, so 28 is the high, 15 is the low. So I'm going to go up by 5, 10, 15, 20, 25, 30. And that should get me pretty close. All right, so January 28.
Miss Boyd, could you please stop by the main office, Miss Boyd?
February 27, 25. So we're just kind of, ooh, I'm already off. So be careful. 25, 22, 18, 16, 15, heading back up. I don't know how accurate this is. If you have paper, you might want to sketch this out better. So it's kind of, you can kind of see that curve, okay? They want us to use a sine curve. So it says first estimate B. Well, we kind of can tell it's repeating itself within a year. So our B is just our period of 12. We take 12 equal to 2 pi over B. So that means B equals 2 pi over 12, which is pi over 6. So anytime this is measured numerically, the number that goes here is going to have pi in it. All right. Next, we're supposed to estimate A. I'm going to put these into place here. So what is A? A is our amplitude. Okay, to find amplitude, that's going to be, we take our high minus our low, divided by 2. The difference of the high and the low, divide, and then half of that. So 13 divided by 2 is 6.5. D is our vertical shift. That's where we average the high and the low. 28 plus 15 divided by 2 is 21.5. Can't see my decimal there. And so when does it start? So what we could do is, when does it start going? When does it hit that middle? When does that hit 21.5? So to me, it made sense. This has all been shifted. This is where it starts the midline and does the actual sine curve. So what we're going to do is go estimate this has gone 10 to the right. So D equals 10, or C equals, where, this was D. Where's my C? Oh, here's my C. 10 to the right. Because I was looking for when did this hit equilibrium and start to go back up again. Okay, so we've got all of our pieces. Now we're just going to plug it in. T equals, A is our 6.5, sine of B pi over 6 times the quantity, little t, minus our 10, that's what shifted it to the right to get to here, plus our vertical shift of 21.5. And that is all of the section D.